Hello everyone, welcome to the lecture again. In the last lecture, we looked at the equilibrium condition for one dimensional object, two dimensional object and three dimensional object. Today, we are going to do more examples on the equilibrium of the rigid bodies in two dimensional systems. So, let us look at the following problem statement. Question number 1. A man raises a 10 kg joist with a length of 4 meter by pulling on a rope, and in the question it is asked to find the tension T in the rope and the reaction at A. So, first let us make a free body diagram of this. So, we have the x axis, the y axis, and we have this joist whose weight is going to act at the center of mass, and it is 10 kg. So, W is 98.1 Newton, and this is going to act at a distance of 2 meter because joist is 4 meter long. At A, we have the reaction forces Ax and Ay. It will not support the moment because it can rotate about A. Now, the tension T will be away from the object, and to find out the value of T, let us take the moment about A. Okay. So, for that I need to know how much is this distance. This is perpendicular on T. So, let us say this point is P, this point is B, this point is A, and so on. So, this is 45 degree, this angle is given, it is 25 degree, therefore, this angle will be 70 degree and this angle will be 45 degree. Now, let us take the moment. About A. So, W into the horizontal distance, which is 2 cos 45 degree equal to T into x. Now, I have to first find out how much is x. Now, you can see here that this angle is 90 degree and this angle is 25 degree. Therefore, sin 25 degree equal to x divided by 4, or x equal to 4 sin 25 degree. So, T will be 98.1 into 2 into 1 over square root 2 divided by 4 sin 25 degree, and this comes out to be 81.9 Newton. Now, the Ax and Ay I can find out using the force balance along the x and y direction. So, let us look at summation Fx equal to 0. So, this gives me Ax equal to T cos 20 degree, because this angle over here is 20 degree, and summation Fy equal to 0 will give me Ay equal to W plus T cos 70 degree, and since the values of T are known, it will be 81.9 cos 20 degree, and this will be W is 98.1 plus T is 81.9 cos 70 degree. These are the values of AX and AY. Now total A will be square root AX square plus AY square, and the angle that A makes from the x axis will be tan alpha equal to AY over AX, and this comes out to be 147.8 Newton, and this comes out to be 58.6 degree. Now let us look at this question. Here the problem statement is following: the 500 kg uniform beam is subjected to the 3 external loads as shown. Compute the reactions at the support point O. So, the first thing is to make the free body diagram of this. So, let us make the free body diagram. Let us say this is y axis and we have the x axis, and this is the uniform beam. Now at point C we have a force of 3 kilonewton which is acting at 30 degree. At point B, which is 1.8 meter away from C, we have a moment and its value is 15 kilonewton meter. At 1.8 meter away from B, we have another force of 1.4 kilonewton that is acting. Now this beam has a weight of 500 kg and the length of the beam is 1.2 meter plus 1.8 meter plus 1.8 meter, which is 4.8 meter. Therefore, at 2.4 meter from C, its weight is going to act. So, this will be W equal to 500 into 9.8, which is 4900 Newton. Now, at point O, we have a built-in support. Therefore, the reaction forces will be Rx, let us say Ry, and a moment MO. To find out the unknown parameters, let us first take the force equation and say summation Fy equal to 0. So, let us look at what are the forces that are acting in the y direction. So, we have Ry plus 1400 because 1.4 kilonewton minus 4900 Newton acting downward minus 3000 cos 30 degree because we have 3 kilonewton force which is acting at C. So, this gives us Ry equal to 4900 minus 1400 plus 3000 square root 3 divided by 2. So, Ry comes out to be 6098 Newton. Now, we can use the force equation along the x direction. So, summation Fx equal to 0. Now, the forces in the x directions are Rx and the component of the 3 kilonewton force in the x direction. So, we have Rx equal to 3000 sine 30 degree, and this gives us 1500 Newton force along the x direction. Now, to find out the moment MO, let us take the moment about C. So, here you have to note that the moment is a free vector. Therefore, this moment 1500 kilonewton or MO, they are about B and point O respectively, but it does not matter. Okay. So, moment about C will be (15,000) plus 4900 into 2.4. So, this is the moment of the weight minus 1400 into 3.6, because this distance is 3.6, plus MO, plus because the moment is in the anti-clockwise direction, minus 6098 cross 4.8, and this should be equal to 0. Now, from here you can find out the moment. It comes out to be 7550.4 Newton meter. Now, note that this moment comes out to be positive. Therefore, the direction of the moment of MO that we have taken is correct. If this would have been negative, then we would have changed the direction of the moment. So, this is correct. Now, let us look at the third example, and here the problem statement is a fixed screen has a mass of 1000 kg and is used to lift a 2400 kg crate. It is held in place by a pin at A and a rocker at B. The center of gravity of the crane is located at G, and in the question it is asked to determine the components of the reactions at A and B. So, first let us make the free body diagram. So, we have the x axis, we have the y axis, and we have this crane. And its weight is acting at 2 meter from point B, and this is 1000 kg. So, 1000 into 9.81 gives you 9810 Newton. This is 2 meter. At 4 meter we have a weight of 2400 kg. So, let us multiply it by 9.81. So, it will be 23500 Newton. Now, let us see, if this point is A, then this point is B. Now, at B we have a rocker support. So, this one is rocker. So, therefore, this will support only the horizontal forces. So, let us call it Bx. It cannot support the By component. At A, we have Ax and Ay forces. Since this one is a freely hinged pin, okay, otherwise this crane cannot go up and down. So, therefore, this has to be a freely hinged pin and therefore, it cannot support any moment, and it is also given that this is 1.5 meter. Now, to calculate the values of Ax, Ay and Bx, let us first use the force balance equation along the y axis. So, summation Fy is equal to 0. So, this gives me Ay equal to 23500 plus 9810 equal to this much Newton. Now, to find out Bx, let us take the moment about A. Okay. So, we have Bx multiplied by the perpendicular distance, which is 1.5 equal to 9810, and from A the horizontal distance is 2 plus 23500 and the distance is 6. So, this gives you Bx equal to 107080 Newton. Now, to find out the Ax, let us take the equation Fx equal to 0. So, this gives you Ax equal to minus Bx, therefore, Ax will be minus Bx is 107080 Newton, and the minus sign indicate that the direction of Ax is not correct. So, we have to change the direction of Ax, and the correct direction should be along the minus x direction. So, therefore, this force is acting in this direction. Now, let us look at the next question, and here the problem statement is following: neglect friction and the radius of the pulley determine A the tension in cable ABD and B the reaction at C. So, to solve this question again, let us first make the free body diagram. So, let us say this is x axis and we have y axis. Here at point D we have a pulley, this point is C and this point is A. Now, from A to B we have a same cable. At this point a force of 120 Newton is acting. So, this is 80 mm, this is also 80 mm and this distance is 200 mm. Now, since the cable is one, therefore, the same tension will act. So, on both AD and BD. Now, at C we have two forces Cx and let us say it is acting in this direction, and Cy. This is given 150 mm. Let us say this angle is theta 1 and this angle is theta 2. Now, to find out the tension T, let us calculate the moment about C, because there are two unknown forces, so they will go away. So, moment about C. So, we will have 120 into the distance, the horizontal distance, it is 280 mm, equal to T cos theta 1. So, I have taken the vertical component, multiply by the distance, which is 200 plus 80 plus 80. So, this is 360 mm plus T cos theta 2 into 200. Now, theta 1 and theta 2 are known, because this is 360 and this is 150. So, therefore, this distance will be 390 mm and cos theta 1 will be 150 divided by 390. Okay. So, we can put the value of theta 1 and theta 2, and this will give you T equal to 130 Newton. Now, we can balance the forces along the y axis. So, let us say summation Fy equal to 0. So, this gives us Cy equal to all the vertical forces. So, we have 120 minus 130 cos theta 1 minus 130 cos theta 2, and this gives you Cy equal to minus 8 Newton. This means that the direction of Cy we have to reverse. So, this is the correct direction of Cy. Now, let us balance the force along the x direction. So, summation Fx equal to 0, this gives you Cx equal to 130 sin theta 1 plus 130 sin theta 2. Again, theta 1 and theta 2 are known. So, therefore, sin theta 1 and sin theta 2 is also known. So, this gives you Cx equal to 224 Newton. Now, total C will be square root Cx square plus Cy square, and this comes out to be 224.14 Newton, and tan theta will be Cy over Cx. This gives you theta equal to 2.045 degree, and its direction will be downwards. Now, let us look one problem which involve the calculation in 3 dimensions. So, the problem statement is following. The vertical post supports the 4 kilonewton force and is constrained by 2 fixed cables BC and BD and by a ball and socket connected at A. Calculate the tension T1 in BD, and further, can this be accomplished by using only one equation of equilibrium. Okay. Now, to solve the 3-dimensional problem, we require the following concept. Let us say there are forces which are acting on the object, and you calculate the moment about O, and let us say this moment is MO. Now, you want to know this moment about a line. Let us say this line is AB. In that case, you take the projection of MO along the line. So, let us say the unit vector along the line is AB. In that case, the moment about line AB will be the moment about O and then its projection along AB. So, here n cap is the unit vector along the direction AB. Now, if there are various forces which are passing through the line, okay, so they intersect this line. In that case, so let us say this is F1, this is F2. If the forces intersect this line AB, then their moment of F1 and F2 about AB line will be 0. We are going to use this concept. So, since in the question it has asked to find out T1, so first let us look at the direction of T1. So, the direction of T1 will be T1 cap, which is BD cap, and this will be BD vector divided by the magnitude of BD, and this can be written as AD minus AB divided by BD. Okay. Now, AD is 4I plus 4J plus 2K. You can look at the diagram, and AD is 10K divided by the magnitude, and this comes out to be 4I plus 4J plus 2 minus 10K and its magnitude, which is square root 4 square plus 4 square plus minus 8 square, and this will be I plus J minus 2K divided by square root of 6. Therefore, T1 vector will be the magnitude which we do not know and which we have to find out, and the unit vector which is I plus J minus 2K divided by square root of 6. Now, to find out the magnitude of T1, let us calculate the moment along the x axis. So, we are going to calculate the moment about x axis. Now, note that this force T2 is passing through the x axis. Therefore, this force will not contribute into the moment. Now, for the x axis, what I will do is I will calculate the moment about A and then take the dot product with I. Okay. So, the moment of the force T1 will be its distance. So, this distance, it is 5 plus 5 K cap multiplied by the force T1 over square root 6 I plus J minus 2K, and for the x axis let us take the dot product with I. For the 4 kilonewton force, the distance is 5K and the force is minus 4J, and let us take the dot product with I. Now, this can be simplified. This is 10 T1 over square root 6 and we have K cap cross I plus J minus 2K dot with I equal to 20 K cross J dot I, and this is T1 divided by square root 6 and we get minus I plus J dot I equal to 2 minus I dot I. Here I have used that I cross j is equal to k and j cross I is minus k. Okay. And this gives you T1 equal to 2 square root 6 kilonewton. Therefore, T1 vector will be 2 I plus j minus 2k. So, we can see that just by using one equation we were able to accomplish the value of T1. With this, let me conclude this lecture here, and thank you for your patience.